The announcement sounds like progress. A major commodity trading giant, Trafigura, has approved a green hydrogen project. Final investment decision has been reached. Capital is committed. Construction is moving forward. On the surface, this is exactly what the hydrogen industry has been waiting for. Projects moving beyond feasibility studies into execution. But then you see the number, 20 megawatts. And suddenly what looks like progress starts to raise a deeper question. If green hydrogen is supposed to scale to gigawatts, why are we still seeing projects at 20 megawatts? This is where the real story begins, because this isn't just about one project. It's about what survives under real system conditions. The project itself is being developed by Morgen Energy, with backing from Trafigura and located in Wales. It's positioned as a meaningful step toward decarbonizing industrial energy use. And it is. But the scale tells you everything about the current state of the industry. Because 20 milliwatt is not a scaling problem, it's a survivability signal. To understand this, you have to step back and look at what final investment decision actually represents. FIDI is not about ambition, it's about certainty. It means that financing is secured, risks are quantified, revenue pathways are defined, and the project can withstand real-world constraints. Most green hydrogen projects never reach this stage. They get stuck in feasibility, delayed by permitting, blocked by grid constraints, or collapse under cost assumptions that don't hold. So when a project reaches FID, it's not because it's large, it's because it works. And that's the first shift you need to make. The industry narrative has been dominated by gigawatt-scale announcements. Massive electrolyzer installations, national hydrogen strategies targeting millions of tons of production. But those numbers exist in a future where everything aligns: cheap renewable power, stable policy support, reliable offtake, and integrated infrastructure. Today's reality is very different. Today, projects are being built only where those conditions already exist. And that naturally leads to smaller, more controlled systems. A 20 megawatts electrolyzer is not small in engineering terms. It represents a meaningful amount of power, significant capital investment, and complex system integration. But compared to the gigawatt ambitions being discussed globally, it's modest. And that's intentional. Because at 20 megawatts, you can control variables. You can align power supply with demand. You can secure offtake agreements that are actually bankable. You can manage grid connection without waiting years in a queue. You can design a system that operates consistently rather than optimistically. This is where the hidden system begins to reveal itself. Green hydrogen is not just about electrolysis, it's about everything around it. The balance of plant, power electronics, water supply, compression, storage, distribution, and most importantly, utilization. If the hydrogen isn't used, the economics collapse. And utilization is where most projects fail. Think about what it takes to keep an electrolyzer running at high capacity. You need consistent power. That power has to be low cost. It has to be available when the electrolyzer needs it, not just when the sun is shining or the wind is blowing. Otherwise, your capacity factor drops. And when your capacity factor drops, your cost per kilogram rises. This is the fundamental constraint that the industry is dealing with. Not technology, but utilization. At 20 megawatts, you can design around this constraint. You can connect to a specific renewable source. You can balance grid imports with local generation. You can ensure that the electrolyzer runs at a utilization level that keeps costs within a survivable range. At gigawatt scale, this becomes exponentially harder. You are no longer optimizing a system. You are trying to stabilize an entire energy network. This is why projects like this one matter. Not because of their size, but because of what they represent. They are proof that under current conditions, green hydrogen can reach FID, but only within a certain boundary. And that boundary is defined by system constraints. One of the most important of these constraints is demand. Hydrogen is not electricity. You can't just inject it into a grid and let it flow. It needs a destination, an industrial process, a chemical plant, a transport application. And that demand has to be stable, because financiers are not funding hydrogen production. They are funding revenue streams. If the hydrogen doesn't have a buyer, the project doesn't have a future. This is where Trafigura's involvement becomes significant. As a global commodities trader, Trafigura operates at the intersection of supply and demand. They understand how molecules move through markets. They understand pricing, logistics, and risk. Their decision to back a 20 megawatts project tells you something critical. It tells you that this scale aligns with real demand. Not hypothetical demand, not future projections, but actual contractable demand. And this is the second shift. The industry is moving from ambition to alignment, from building as much as possible to building what can be used. Because unused hydrogen is not just wasted energy, it's financial failure. Now layer in another constraint: infrastructure. Hydrogen is notoriously difficult to store and transport. It requires compression or liquefaction, both of which consume energy and add cost. Pipelines are limited. Storage facilities are scarce. So most projects today are being designed around local use. Produce hydrogen close to where it will be consumed. Minimize transport. Reduce losses. This naturally limits scale. A 20 megawatt project can be co-located with its demand. It can feed directly into an industrial process. It can operate within an existing infrastructure footprint. A gigawatt scale project, on the other hand, requires an entirely new infrastructure layer. New pipelines, new storage systems, new distribution networks, and those don't exist yet at scale. Then there is the grid. This is one of the least discussed but most critical constraints. Connecting a large electrolyzer to the grid is not straightforward. In many regions, grid capacity is already constrained. Connection queues can take years, upgrades are expensive and slow, so developers are forced to either wait, pay for upgrades, or reduce their project size. Again, the system pushes towards smaller, more manageable projects. What you are seeing with this Trafigura-backed project is the convergence of all these constraints: power availability, demand certainty, infrastructure limitations, grid access, financing requirements. When you overlay all of these, the optimal project size today often lands around tens of megawatts, not gigawatts. This is not a failure of ambition, it's a reflection of reality. And this is where the industry is at a critical turning point. Because the question is not whether green hydrogen can be built, it's whether it can scale beyond these constraints. And that requires changes at the system level, not just the technology level. You need cheaper electricity, not just renewable, but consistently low cost. You need higher utilization rates. That means better integration with the grid and energy storage systems. You need demand to grow not just in volume, but in reliability. Long-term offtake agreements, industrial commitments, policy support that translates into actual contracts. You need infrastructure to catch up: pipelines, storage, distribution networks. And you need capital that is willing to fund not just individual projects, but entire systems. Until those conditions are met, 20 megawatts is not a stepping stone, it's a boundary. But boundaries can move. And that's where the future scenarios come in. If electricity prices continue to fall, if electrolyzer costs decrease, if carbon pricing strengthens, if industrial demand for green hydrogen increases, then the optimal project size will expand. What is 20 megawatts today could become 100 megawatts tomorrow, 500 megawatts in the next decade. But that expansion will not be driven by ambition alone, it will be driven by alignment across the system. And this is the key insight. The hydrogen industry is not scaling linearly, it's scaling conditionally. Each increase in scale requires a corresponding increase in system readiness. Without that, projects remain small, localized, and carefully optimized. So when you look at this 20 megawatts project, don't see it as underwhelming, see it as a signal. A signal of what works today, a signal of where the constraints are, and a signal of what needs to change for the industry to move forward. Because the real question is not why this project is only 20 megawatts. The real question is what it would take to make it 200 megawatts. And that answer doesn't lie in the electrolyzer, it lies in the system around it. And this is exactly where developers, consultants, and investors need to focus. Not just on technology selection, but on system design, on aligning power, demand, infrastructure, and finance into a configuration that can actually survive. Because in this industry, survival is the first step to scale. If you want to go deeper into how these systems are structured, how projects reach FID, and why most don't, explore the tools and frameworks inside H2 Hub by Morgen Energy. It's designed specifically for professionals working at this intersection, where engineering meets economics, and where projects either move forward or quietly disappear. Because the future of green hydrogen won't be decided by the biggest announcements. It will be decided by the projects that actually get built. And right now, those projects are telling a very clear story.